Okay, let's try this again. So let's take a look at how we could use the first derivative to test for local extrema. And here are some things. I know there's a lot in here, but we should talk about the specifics. Okay, recall that a critical point is when the derivative is 0 or when the derivative is undefined. If you need to write that down, write that down. So that's how we find critical points. At those critical points, if the derivative changes sign from a positive to a negative, that would mean the original function is going from a increasing function to a decreasing function. That means there's a local maximum. Okay? It's going from a positive slope to a negative slope. If the derivative changes sign from negative to positive, that means the function f of x is going from decreasing to increasing. That would mean a local minimum. Second scenario is sometimes critical values do not have to be extremas. If there is no sign change, then f has no local extrema at that point. An example of that, if you flip back to the first page, would be something where C1, for instance. The derivative is a positive number. That means the function is increasing. The derivative is 0, there's a leveling off, and then it's still increasing. This is nothing. We still need to address it, we need to check it out, but this is not an extrema. So just because something's a critical point doesn't mean it's necessarily an extrema. Now, at a left endpoint, okay, if the derivative is less than 0, okay, for x is greater than 0, then f has a local maximum or minimum value at a. I mean, it's the same thing, it's just matching up. If the derivative is less than 0, as it's going through an entire rest of the interval. Okay, so we start at an endpoint. We know that the function is decreasing past that endpoint. We know that the endpoint had to be a maximum, and vice versa. If a function is at an endpoint, so let's say a function starts here, we know the derivative is positive. If the derivative is positive, well, we'll start here. If the derivative is positive, we know that the function is increasing the entire time, then we know that that had to be a minimum point on the graph. Same thing with at a right endpoint. Those things are things we need to address when we cannot look at the graph specifically. Okay. Let's use the first derivative test to find relative extrema. Why I have intervals there, we're going to use a sign chart to do this, is because the sign chart helps us decide what kind of values the function is, and then, or the derivative is, which helps us decide what the function f of x is doing. Okay, so the first one we're going to do is x cubed minus 27x plus 3. So the first thing I'm going to do is come up with some intervals. I'm going to figure out what the critical numbers are. So I'm going to find the derivative. This function is not defined anywhere, so to find the critical number, I want to find where the function is 0. Don't forget, when you take the square root of this, it is plus or minus the square root of 9, so plus or minus 3 equals x. These are critical numbers, therefore they are potential sign changes. So one thing I kind of like to do with this is do a little sign chart then. I mean, we can do this in, I guess, above as well. But this is -3 and this is 3. And then I am doing this for simply the derivative. This is now. I'm trying to figure out if it's positive or negative. Okay? So if I pick something to the left of -3, for instance, -4, and I put it in here, negative 4 squared times 3 minus 27 is going to be a positive number. Between negative 3 and 3, I will pick 0. If I put 0 in for x minus 27, that's going to be a negative number. And then to the right, let's say I put positive 4 in. Put positive 4 in for this, if I would square it. And I can tell I don't have to find the exact value, I'm just looking at the sign of it. Okay, so I have 3 intervals here. I have the intervals negative infinity to negative 3. And then I have the interval negative 3 to 3. And then I have the interval 3 to infinity. F of x is greater than 0. Don't write positive. The AP would like you to write it this way. What does that mean about the function? If the derivative is positive, that means the function is increasing. Between negative 3 to 3, we found that the derivative was less than 0. What does that say about the original function? That it was a decreasing function. And then, from 3 to infinity, the function, or the derivative of the function, was again greater than 0. So it was increasing. Just sketching then, I don't know what's going on, but if I know that the function is increasing and it switches to decreasing, and then it's decreasing and it switches to increasing again, that first negative, when x was negative 3, would be a maximum, and this would be a minimum. Okay, we know where they occur. Okay, so we know where they occur, we just don't know what the actual extrema are. So let's actually find them. F of negative 3 would be 3 times negative 3 squared minus 27. And so, oh, sorry, my bad, my fault. That's going to be a 0. This is the function, f of negative 3. I was using its derivative. Okay, so I'm going to have negative 3 cubed minus 27 times negative 3 plus 3. Okay, that's 27 minus 81 plus 3. That should be, let's see, a negative 51. For f of 3, we have 3 cubed minus 27 times 3 plus 3. Man, I have lots of mistakes today. This was actually a negative 51. This should have been a negative 27. Plus 81 plus 3. Because a negative times negative is positive. Okay. So if I was writing this up, my justification would be to use the first derivative to do that. So there's a local max of 57 at negative 3. Since f prime of x switches from positive to negative. And then a local minimum at 3, negative 51, since f prime of x switches from negative to positive. And you need to tell me what function you're talking about, so we do need to mention the derivative in there. This should be from. I can't read that. Okay. Let's take a look at the second example. So this is asking a little bit different question. We're going to find the critical numbers of the function and identify any relative extrema. We're going to also identify the intervals on which f is increasing and decreasing. I think I might run out of time on this, so this might go into a second video. So to find the critical numbers, we're going to find where the function is undefined or 0. So this is product rule. Let's find the derivative first. First times the derivative of the second would be times 2x plus second d first. The derivative of the first is still e to the x. Alright, so they both have a common factor of e to the x. I'm going to pull that out to the front. And then if I put these things together, I have 2x plus x squared minus 3. That would be my equation for the derivative. To find critical numbers, I need to find where the derivative is 0 or undefined. So e to the x and x squared plus 2x minus 3 are both continuous defined functions on their entire domain. So they are not undefined anywhere. And they're 0 where e to the x would equal 0, or where x squared plus 2x minus 3 would equal 0, since they're a product of things. E to the x never equals 0. So we need to figure out where x squared plus 2x minus 3 equals 0. To do that, you can use quadratic formula, or you can use factoring. I am going to use factoring. So I factor into x plus 3, x minus 1. The zeros of that would be x equals negative 3, and x equals 1. So that leaves me with several different intervals. I have a 0 at negative 3, a 0 at 1. I guess I don't need to make it go on that far. Let's keep in mind, guys, I'm going to use my derivative function, which is up here when I'm doing my sign chart. By the way, a sign chart is not good enough justification. You need to simplify into a chart like that and tell me where the derivative is positive and negative. Okay, so when I'm putting in any value for x, think about e to the x, this function. E to the x is always a positive number, okay? So let's pick something to the left of negative 3. Let's say I picked negative 4. E to the negative 4 is going to be a positive number. If I put negative 4 in here, let's see, that'd be negative 4 would be like 16. 16 minus 8. 8 minus 3, that's still positive. So positive times positive is positive, or you can use an addition. Between negative 3 and 1, I like to use 0. E to the 0 is positive. If I put 0 in here, I get a negative number. And positive times a negative number is negative. If I put something to the right of 1 in, like 2, e squared would be a positive number. And then, let's say I had 2 squared plus 2 times 2 minus 3. That would leave me, let's see, 2 squared would be 4. 4 plus 4, 8 minus 3 is positive. A positive times positive is going to be positive. Okay, I'm almost running out of time, but the next thing I would do is put the intervals up here.